안 되는데?
심각한데? 이쪽 가야 돼. 자, start.
Hi everyone. Hi everyone. I will start the last presentation. My team members are 서지용, 이재원, and presenter me, 윤상철. My presentation consists of 3 parts: introduction, operating principle, and application. Let's begin introduction of the spotter. First, what is the spotter deposition? A few years ago, everyone had experience in seeing the spotter in laboratory. And when Lowe's did this equipment through the report. Oh. So I briefly explain the spotter. The spotter is pivot method of deposition thin film by sputtering. In this picture, this is the structure of the dish style sputter. This part is source material is called target material. It connected to cathode in order to attract positive. And this is the reason why this sputter is called. This sputter is called the dish style sputter. In the sputter, the main process is the sputtering. The sputtering is a process whereby atoms are ejected from solid target material due to bombardment of the target by energetic particles. Here, these energetic particles and target material collide, and then atoms or ions are ejected from target material. The injected gas which collide with target material is often argon gas. At 100 milliliters of argon pressure, the deposition rate is the highest. And when argon gas change into plasma state, this process occurs. Next, I will talk about advantage and disadvantage. The first advantage is this method deposit various materials such as elements, compounds, and alloys. The second, the material having very high melting point are sputtered because this deposition doesn't need to vaporize source material. Third advantage is better addition on substrate compared to evaporation deposition. And the chamber has a small volume. For the last, this deposition can coat large area more uniformly. And disadvantage, one of the disadvantages is that this deposition is difficult to create structural patterning. Second, the inert gases can interrupt the deposition of the source material. This is because the inert gases are built into growing film as impurity. Also, this method is difficult to do active control for layer by layer growth compared to other deposition. In this page, I'm gonna tell you about operation principle through the simple figure. In the initial state, the chamber is filled of air. First, in order to increase the mean free path and reduce the energy loss over argon gas, we have to create a high vacuum state in chamber. At HV state, injects argon gas, and the inner gas receive high energy in order to turn into plasma. Next, the target material connect to cathode, and then positive ion argon gas is attract to target material. 잠깐만. target material. So the sputtering is occur, and source of material deposit on the substrate. In this way, the sputter dispersion is working. Finally, I introduced the several stuff which are produced using this technique. The first thing is the protection film of this display screen on smartphone. In the right side picture, you can see that the thickness is few micrometers. This thin film is made using this deposition and other deposition. Next application is thin film solar cell. Its thickness is also nanometers to micrometers. The other example is DVD, CD, hard disk, semiconductor, and so on. Likewise, there are so many products which are produced applying this position. To conclude, I would like for you to remember two things. First, sputtering process. Second, operation principle. Thank you. Have a question?